IITJEE.
Alright folks, let's do some practice with position time, velocity time, and acceleration time graphs. So here we have three graphs. One is an acceleration graph, one is a velocity graph, and one is a position graph. Let's read the question. The first figure below shows the AT graph for a certain setup. The second figure shows the VT plot for a different setup. The third figure shows the XT plot for yet another setup. Now here's the thing. These three setups are completely independent of each other. So this VT, this AT, this VT, this XT, they're mutually exclusive. They have nothing to do with each other. Which of the 12 labeled points corresponds to zero acceleration? Okay, zero acceleration. Well, first let's look at our AT graph. Where can we find zero acceleration from here? Well, zero acceleration is going to be where the acceleration is zero. In other words, when we have an x-intercept, like at this point, B. Okay, can we look for where acceleration is zero in this graph, in this VT graph? Well, yes, we can. We can find where acceleration is zero on a VT graph by using the concept of the derivative. Remember, the velocity goes to the acceleration when you take the derivative with respect to time. And so taking the derivative is the same as taking the slope. So to find where my acceleration is zero on this graph, I have to see where the slope is zero. So let's try it out. Is the slope zero here? Looks like it. So E is a point of zero acceleration. How about F? Slope is definitely not zero there. How about G? Once again, slope is not zero. Finally, H, you can see the tangent line is horizontal. That means our slope is zero. That means our acceleration is zero at point H. So already we've found 3 points, B, E, and H. Let's see if we can find any more. How do you find where acceleration is zero on this graph? This is an XT graph, a position versus time graph. How do we know when acceleration is zero? Well, position is the third piece in this puzzle. To go from position to velocity, we take the derivative. To go from velocity to acceleration, we again take the derivative. Okay, and of course to go backwards, you can take the integral. Now, here's the thing. How do you find acceleration from position? And that's something most people get tripped up on. Well, if you're taking a derivative and a derivative, that's the same thing as taking the second derivative, which is all about concavity. And where is our concavity at a maximum, aka where is our second derivative equal to zero? Well, it'll be at the inflection point, this point K. This inflection point, this K point, is where the slope is changing the fastest. In other words, this is where our acceleration is zero. Why? Well, think about it. Here the slope is, here the tangent line looks like this. Here the tangent line is this. And here's where the tangent line maxes out, and then the tangent line goes back to zero. So the tangent line starts at zero, ends at zero, so it must have had a maximum at some point. And that maximum happens at this point of inflection, at this K. And so that's where the acceleration is going to be zero on this position versus time graph. And so we have the 4 points where our acceleration is zero to be B, E, H, and K. And that's the answer, folks. Thanks for watching this episode. We'll check you out in the next one.
Embedded plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.